This is lesson 6. It's our last lesson in unit 11. We're looking at right triangle trigonometry today. A triangle where one angle is 90 degrees is called a right triangle. The adjacent side is any side of a right triangle that is next to the angle of interest that we're calling theta. So the adjacent side. In our triangle here at the right, the adjacent side to theta is side B. Also, any side of a right triangle that is across from the angle of interest is commonly called the opposite side. And again, back to our picture, the opposite side here to theta is going to be side A. It's opposite our angle of interest that we're calling theta. And finally, the longest side of the right triangle is called the hypotenuse. This side is located across from the 90-degree angle. And normally, if you have a side that's lowercase a, then the angle opposite that side is capital A. And the side lowercase b, the angle opposite that side is going to be capital B. And the side that's the right angle is going to be capital C. So as we get further into the trigonometry, you'll often see triangles like that. So if we let theta be any acute angle in that right triangle ABC shown above, then the sine function is going to be the opposite side of theta divided by the hypotenuse of theta. So that's side A divided by side C. And cosine is the adjacent side divided by the hypotenuse. That would be side B divided by side C. And tangent would be the opposite side divided by the adjacent side. And that would be side A divided by side B. Now, the reciprocal functions, cosecant is the reciprocal of sine, so we take the reciprocal hypotenuse over opposite, which is C divided by A, and secant is hypotenuse divided by adjacent, which is C divided by B, and cotangent would be adjacent divided by opposite, and that's found by dividing side B by side A. In our two famous triangles that we saw before, we had created the relationship where this side is 1 and this side is 1, so the hypotenuse would be square root of 2. And when you simplify and rationalize the denominator, opposite divided by hypotenuse would be square root of 2 divided by 2. So this side, the cosecant, would be square root of 2, hypotenuse divided by 1. And cosine and sine in a 45-degree angle are the same. So cosecant and secant are the same. And then tangent and cotangent are both 1. And that's using our special 45, 45, 90-degree triangle from geometry. Now notice in a 30, 60, 90 triangle, for example 2, when we look at the relationship of the sides to the angles, let's put the 60-degree angle here. The side opposite the the side opposite the smallest angle is the shortest side, and the side opposite the 60-degree angle is x square roots of 3, and the hypotenuse is 2. Again, when we use the relationships for the trig function, sine of 30 is opposite over hypotenuse, then our opposite over hypotenuse in this case is going to be 1/2. And if we flip that over, cosecant hypotenuse divided by 1 would be 2. Cosine is adjacent to hypotenuse. So flipping that over and rationalizing the denominator, 2 square roots of 3 over 3 would be our final result. And then tangent is opposite divided by adjacent. That's 1 over radical 3. And I'm rationalizing 1 over radical 3 to end up with radical 3 over 3. And adjacent divided by 1 is just radical 3. Now consider with me, if we take that same triangle and stand it up, the 60 degrees is down here on our base, but our 30 degrees would be up here. So 30 is the smallest angle. Across from the 30 is the shortest side. Across from the 60 is radical 3, and our hypotenuse is 2. So we're going to see some interesting things happen. Opposite divided by hypotenuse is radical 3 over 2. Flipping that over, rationalizing the denominator, we're going to get 2 radical 3 divided by 3. Cosine of 60 is a half. Flip that over, secant of 60 is 2. Tangent of 60 is radical 3. And 1 over radical 3 rationalized is radical 3 over 3. So now moving on to the next, let's compare the 6 function values for 60 degrees with the 6 function values for 30 degrees. And what do you notice? So pause the video a minute, think about what patterns you see, and then come back. We'll discuss that together. So hopefully you noticed that if we had complementary angles such as the sine of 30 and the cosine of 60, 30 plus 60 have a total of 90 degrees in all, that the sine of 30, which was 1/2, was the same as the cosine of 60, which was 1/2. And vice versa, the sine of 60, which is square root of 3 over 2, is the same as the cosine of 30. And then again, the tangent of 30, which was radical 3 over 3, was the same as the cotangent of 60, radical 3 over 3. So I summarized it this way, that any sine and cosine combination whose angles added to 90 degrees had equal trig ratios. And the same goes for any tangent and cotangent complementary angles are going to be equal trig values. So if you said it in some fashion like that, I think you have a good understanding. So let's move on to example 4. We're going to use one trig ratio to find the other 5 trig ratios. In this example, we let theta be this acute angle down here on the bottom, and the sine is 3 over 5. So sine's trig ratio is opposite divided by hypotenuse, but it's got to be opposite our angle of interest, which is theta. So opposite is 3 and hypotenuse is 5, and if we use the Pythagorean theorem, we'll find that this is a 3, 4, 5 triangle. So now we can say the sine of theta is 3/5. That was given to us. This was the given. So if we start out with this given information, cosecant is 5/3. And cosine is adjacent divided by hypotenuse. So adjacent to our angle of interest is 4. And the hypotenuse is 5, so cosine is 4/5, and secant would be 5/4. And lastly, opposite to adjacent would be 3/4, so cotangent would be 4/3. So that's fairly simple. Some of the common errors that you make if you're using a calculator is that you might be in the wrong mode, or that you might use the inverse trig keys to evaluate cotangent instead of using the inverse trig keys. You raise the function to the power -1. So you want to make sure if you have cotangent, there's an inverse trig key, and cotangent doesn't mean tangent to the -1 power. So using function shorthand that the calculator doesn't recognize, our calculators don't evaluate when you have sine squared x. You have to put sine of x in parentheses and then square your result there for the calculator to properly evaluate. And then the last common mistake is not closing parentheses. Always be sure that you have pairs of parentheses. So if you'll grab your calculator to find the tangent of 120, I get -1 7/10. To find cosine of 225, I get -7/10. And here's cosecant. So if you have the TI Inspire, your calculator has a cosecant button. But if you have a scientific calculator, you can use 1 divided by sine of pi/3 and get the same answer as using the cosecant key if you had a more sophisticated calculator. I have 1.2. And then same for secant, you can do 1 divided by cosine of 5 pi/6, or if you have the secant button, you're going to get -1.2. Example 5, we're going to get an approximate answer using the triangle that's shown. We've got a 7, 24, 25, and the sine of theta is opposite our angle of interest divided by hypotenuse. So opposite over hypotenuse. This is our angle of interest. This is the opposite side. This is the adjacent side. And 25 is our hypotenuse across from the 90. So sine of theta is 7/25. Its reciprocal cosecant would be 25/7. Cosine of theta is adjacent to hypotenuse, so secant is 25/24. And tangent is opposite to adjacent, so cotangent is 24/7. And those are the exact values. Then we want to go back to get the approximate values. 7/25 is going to be 0.28. 25/7 is going to be about 3. Let's see, to the nearest tenth. So 5/7, that would be tenth. If we go sine of theta to the nearest tenth, that's about 3/10. Cosine 24/25 is about 0.96. So to the nearest tenth, that's about 1. And 25/24 to the nearest tenth is about 1.04. So again, 1. And 7/24 is 0.29, so roughly 3/10. And 24/7 is about 3.42, so 3 4/10. So we've given an exact value and an approximate value. Then our last example is a real-world example. Let's say you have an observer standing 18 feet from the side of the building, so the observer is down here, and that top of the line of sight to the top of the building, that's 65 degrees here, and we want to find the height of the building, so we're going to make that assumption that this is perpendicular for the height. So I believe we could use the opposite side over the adjacent side. That sounds like the tangent of theta to me, opposite divided by adjacent. So setting that up as a ratio, tan of 65 is the height of the building divided by 18 feet. So using cross multiplication, 18 times the tangent of 65 is going to give us the height, and that height is approximately 38.601. It's in feet, and if they want us to round to the nearest foot, then the height of the house is just about 39 feet tall. And that finishes up chapter 11.